Let's learn how to use the Arbitrary Waveform Generator function of the NI myDAQ. As we get started here, always bear in mind that the pair of analog outputs have a limit of plus and minus 10 volts for their maximum output and a 2 milliamp maximum current drive. I'm using the specific wire connections here to direct the analog outputs back around into the analog inputs. Let's begin by launching the Arbitrary Waveform Generator. Alright, we have the display area. This will depict the waveform itself when we're all done. We can direct it to either or both of the two output channels. You can also direct it to the audio outputs, the left and right channels. Here you specify a waveform file, a file of sample points. You can adjust the amplitude of the waveform. And here you specify the samples per second, which is basically your time resolution. You can generate the waveform once, or more commonly just run it continuously. Let me start the waveform editor, and let's go ahead and start creating some specific waveform shapes. For this demonstration, I'm going to use a sampling rate of 50, or taking it from 50 rather, and going to 10 kilohertz. And it defaults to, it might be a different value in your case, but it's easily changed. I'd like to set this value to 5 milliseconds first. I'll add another segment, 20 milliseconds duration. So at this point we see there's the 10 millisecond segment, here's the 20 millisecond segment, and the 5 millisecond segment. So you can work on individual pieces of the waveform. When I add a component, then I can choose from the list over here. I'll use DC level for the first one. Let's go ahead and add a more interesting shape here. I'll pick sinusoid for that. And notice then you can adjust things like the amplitude, maybe give this a little bit lower amplitude. You can adjust the frequency. And again, if you need a little bit more resolution, you can highlight a digit, and then I'm using the arrow keys at this point to more conveniently scroll through the values. I want to choose a phase that gives me a little bit more of continuity from the first segment to the second segment. So I'm looking at that region right there. And for this last component, again, lots of options here. Let's go ahead and do trapezoid for that. Alright, at this point the waveform has these three different segments. Notice that you can actually have more complicated shapes built up by combining multiple components together. So for example, in this region where we presently have the sinusoidal component, I can add another component. What looks good? Let's try circle. Notice that you can then combine the components through the basic math operations such as addition, subtraction, multiplication, and division. And FM stands for frequency modulation, so that would be another option as well. So I'm just going to kind of play with this a little bit until I get a shape of sufficient amount of interest here. That looks pretty good. Kind of like a sinusoid with some extra wiggle components tossed in. Now I also want this first DC level to be a little bit different. Let's set that to 0.6 instead. Alright, I think that's enough for illustration purposes here. I'll also point out that you have different ways of viewing each of the portions of the overall waveform. You have some other options in terms of the way you think about the waveform, whether or not you're looking at time or frequency domain. Also, the way that you look at the waveform can be varied. So here we're looking at the actual sample points. And these give you the ability to zoom in and look at the plot in different ways. All right, let's go ahead and first save this away as what we call the waveform editor file. And this is necessary for you to later on edit your work here. So especially if you close everything down and you wanted to retrieve the waveform for later editing, you have to save it away in that file type. At the same time then, you also need to save it in the waveform data file, or WDT for the extension. I'm putting these all on the desktop incidentally. And that second file then is how the waveform generator actually retrieves the information. All right, for my second waveform, I'll just do this a little bit more quickly since I think you've got the idea. Let's go with the stair-step function. And I'll just go ahead and save that to waveform data type. I didn't have to invest so much work in that one, so I'm not going to bother saving it away as the editable format. All right, I'll associate my more complicated waveform with analog output 0 and the stair-step waveform with analog output number 1. You have to then enter the update rate according to your work back here. So 10 kilohertz was the samples per second. It's good to bear that one in mind because that one does not get loaded automatically when you load up the waveform file. We then enable both channels, go ahead and hit run, and whoops, it says the number of samples to write must be the same for every channel. If we look at the graph, you can actually see that the first waveform we created is in fact longer than the step waveform. So at least for a continuous output, then we need to really specify the same number of samples for both channels. So you can look at the time display and confirm that we do have 35 milliseconds total. That means I need to add another 25 milliseconds to the stair-step waveform. Well, one thing I did want to draw your attention to is you have access to the usual copy and paste and cutting and so on that you're familiar with from other Windows type applications. All right, let's change that to 25 milliseconds. And I'll just make that another stair step. I'll go ahead and load that again. And we're good to go. It's operating. It says we're generating 10 kilosamples per second. Now both of these waveforms are appearing on analog output 0 and analog output 1. Let's use the oscilloscope to view both of those analog outputs. Again, remember I've got the connector set up specifically so that the oscilloscope can observe analog output 0 and analog output 1. So at this point I'm setting it up to use the analog inputs to view those corresponding outputs. Alright, we recognize the green trace, that was the one with the kind of wiggly sinusoid, and the blue trace is our stair step. I'm going to see if I can stabilize the display a little bit by using edge triggering. And at the moment I'm triggering on channel 1, which is the blue trace. And it's a little bit of ambiguity in triggering because we've got multiple slopes that meet the triggering criterion. Let me switch this over to triggering on channel 0 instead. Okay, that works pretty good. Now just to be able to see these a little better, let me change the volts per division. You can also adjust the time base here. Again, we see that the waveforms are definitely being produced on a repetitive basis. And I think everything looks pretty good.